So to run through, avoid launch fails with load testing. Some background here. Obviously, we're looking at what happens when you go from working on a site locally or even on a test environment. We have test servers oftentimes. What happens after that once you open it up to the gates of the public, and what happens kind of to your website over time as swaths of people kind of hoard around to your website. We've had some issues in the past with opening the floodgates up. I know Kaylan, working at a hosting company, has had a lot more experience with this, but this has been a focus just at MindGrub, kind of across the board. We're looking to add some base level automated testing that we can keep an eye on this sort of thing moving forward without having to constantly pull people to go and figure out, hey, what's the absolute stress breaking point of your website? Little about us.
Yeah, so that's me. I'm Kaylan. I'm a senior customer success manager at Pantheon, like mentioned. I do a lot of work with load testing in my day-to-day, helping customers either pre-launch or before a big event, just to make sure that we've got them set up correctly. Also, if they're pushing out like a big new feature and want to make sure that pushing out the feature isn't going to tank their website performance. Yeah, you can go ahead and hit the next slide, Chris. And just as a heads up, Pantheon is hiring. We have a lot of open positions, so feel free to click on the now hiring thing. We'll make the slide deck available in the meetup, or you can just ping me and ask, and I'll be happy to talk to you about it.
Cool. My name is Chris. I'm an engineer at a company called MindGrub. We're actually out of Baltimore. My heart and home is still in South Carolina, though, hence South Carolina Drupal Meetup. Like everyone, we're hiring. To jump into the meat of it. This is actually one of my favorite topics anytime it comes up around testing. Testing is an even newer school of science and engineering than software engineering. Software engineering has been around realistically since the late 60s. We've had a lot of time to talk about what it means, what things are different, and kind of build a vocabulary. Testing is different, and I find that it often means different words mean different things to different folks that are testing. So I like to build up a lexicon before we kind of dive in load testing, just to understand what we're talking about when we say load testing, performance testing, and the such. When I say performance testing, I just want to understand how my site will react under given circumstances. If I'm dealing with bridges, I want to understand how many cars and how much weight can go over top before things start to buckle, before some stress is placed on the concrete, before I expect that concrete to start to crack and some of the reinforcement bars to bend. I just want to understand how it reacts to different iterative loads. In software, this is often, I want to understand how it reacts to what I expect the average traffic to be, how it would react to a little bit higher traffic to be, and I just want to make sure that some of Drupal's idiosyncrasies like caching and other things scale how I expect. Sometimes things don't scale evenly and you'll have some weird cracks and stresses show up. Load testing is where we're not really trying to determine and verify that we can handle certain loads. It's just where we're going to increase the load and stress within the system to understand exactly where the breaking points are and what they look like when it finally breaks. If I was testing a rope, I want to understand how much weight the rope can handle before it starts to fray and stretch. I also want to understand maybe if I pre-stress the rope where I fray some of the threads, what effect does that have as I increase the load testing on it, increase the amount of weight I'm trying to lift with a rope? And what does it look like when I finally try to lift a weight that's too strong from it? Does it completely snap? Does it slowly fray and kind of disintegrate and drop the rate? The same with websites. I want to understand exactly what it looks like when the website or software just has that massive influx of traffic and it starts to kind of cripple and keel over dead. Stress testing is kind of like load testing. The only difference is we're going to kind of pre-stress the environment. This is things like maybe we'll load test where we'll drastically increase the amount of traffic and iterate that over and over and over again. And we'll do things like clear the cache in the middle of the load test or removes one of our two SQL servers, or see how it tries to handle maybe turning one of the two servers off and seeing how it can handle different stressful situations. The idea is, we're really trying to understand where our weaknesses are and what the worst case scenario are, so we could respond accordingly. So this is kind of to build a common vocabulary of what we're all talking about when we say performance, load, and stress testing.
So just to kind of help get us started, we thought that we would talk about a situation where load testing either wasn't done or wasn't successful. A situation where, we were able to find and solve a problem, and then kind of different ways to use load testing tools. So starting off with healthcare.gov, this is very big in the U.S. news. If you're familiar with it, I assume being in the web industry, most of us have heard about what happened here. They launched this massive system, and then it went down basically almost immediately. So part of the things, Chris, if we can go to the next slide. Thank you. Just a little bit of the statistics about what's going on. Essentially, it was unusable on day one, which was highly unfortunate. They were down within 2 hours. Only one person, or no, 6 people got their application submitted on the first day. There were a lot of things that contributed to how this happened. If we can go to next slide, please. The biggie, obviously, being that the launch date was mandated. It was written into a law, which meant that you couldn't change it. They had to put it up. And so a lot of the things that struggled and failed in this were testing and troubleshooting. So there really wasn't load testing performed. There wasn't stress testing performed. There wasn't really anything done. And even if they had done it, they would not have allowed themselves enough time to actually react to the test results. So that's kind of an important point to make, that, when you're doing these kinds of testing, doing the test 10 minutes before you're going to launch the site doesn't really help a whole lot, because if you do uncover a problem, there's really not enough time to do anything about it. So it helps to actually plan this into your timeline. What Pantheon, one of the guidelines will say is, we want to know that you want to load test 2 weeks before you launch, so that gives us a week to schedule it and a week for you to respond, which means that your site is code complete or feature complete at least a week before the launch, or as close to as possible. There's always going to be a little bit, but basically, if you do a load test and then you push a major new feature, you essentially nullify the results of your load test. So another situation that I personally ran into with a customer of mine. Sorry, speaking is hard today. I've talked in a lot of meetings so far today, so English is getting hard for me again. We had a customer who had a large kind of nonprofit organization. Their primary form of income is donations. They were using a Salesforce connection to pull in data from users, basically on login. So if somebody logged into the site, they would call out to Salesforce and pull in the most recent updated information, how much money they donated, whether they were up to date, whether they had like past invoices, like anything like that, so that they could just get this information on the fly. Unfortunately, when they actually had the site live, the data was not actually coming down, and it was causing a lot of problems. Users were logging in and not being able to access, payment information or like past donation information. And it was difficult to figure out what was going on, because obviously this is a production environment. You don't want to do too much on it. You don't want to just push out random code to see if that fixes it. So what I did with the developer is we actually used the load testing framework to put a clone of the site under load, so that we could mimic throwing tons of users at it. We wrote out a custom script that would mimic users logging in and logging out, visiting different pages. And we're able to actually utilize New Relic, he was able to use XDebug because we could point this at his local machine, utilize XDebug to figure out what was going on. And then we could also use the framework to test the theories behind how to fix it. And then once the code was actually written, could test and verify that, yes, this did in fact fix the problem. So that was a cool use for the load testing tool.
I think, and after this, I know if everyone's not familiar with New Relic, I can actually pull up an example of what that looks like. New Relic is just a performance tracking tool that gives you real-time kind of performance statistics on your website usage. It's similar to Google Analytics, but it's more tuned and dialed into some of the nuances of your application, and in this case, specifically Drupal.
I wouldn't say that it's like Google Analytics at all, actually,
Cool.
personally, just for the record. Very much performance based of the server settings for your system. And if you have caching in front of it, it doesn't show any of the caching traffic where Google Analytics would. But anywho, carry on.
Cool. So we talked about some examples when not load testing has really been costly. So when to load test, there's a handful of kind of red flags that should be thrown when you should do this. I've done this a variety of ways in the past. At times we've literally had as many people in the office open up as many browsers as they could and spam refresh as quick as possible. After that, we did some basic scripting. We wrote some small programs to go through and effectively do the same thing. But specifically, we always usually coincided this with new launches. We wanted to understand, here's a new site, either we were redoing a site for an existing property or it's a brand new site and we're about to tell the public about it. And there's going to be some amount of new influx of traffic that we haven't previously subjected it to. So we want to understand what that's going to do to the site and make sure that we can survive on the day one launch, unlike poor old healthcare.gov. Major feature releases is another one, like Kaylan alluded to. When you're rolling out new features, sometimes that can have really strange consequences where everything works flawlessly when you're looking at it on your computer. It'll even look great when you and maybe someone else is helping test it. When you test it on the testing server where it's just you and them looking back and forth at it, it'll work wonderfully. But as soon as you subject that feature to hundreds of users, it could have a nasty side effect. So it's always useful to rerun your load testing and really the majority of any of your testing suite after you have a major feature release. Bug fixes is nice. This in practicality kind of gets swept under. We try to do it on a regular cadence. It's time consuming to run a lot of tests, but we try to make sure if there's a major bug fix or to run this as iteratively as we can in between bug fixes, just so again, we have an idea of what the stress points are going to be on the application based on the changes that we've made. This is an interesting one, a major marketing event. Sometimes you don't even have to change your site. Sometimes nothing could be wrong with your site. Everything could be operating exactly as you expect within normal parameters, but maybe you get picked up by a popular Twitter account, or you have that viral new marketing push that hits the mainstream, and all of a sudden your traffic goes from 100 concurrent users to 100,000 concurrent users through no fault of your own, and your poor site has never seen more than 100 users at a time. So if you're going to plan major marketing event where this is the end game and you're trying to increase traffic by a lot and you're doing maybe a huge market spend or something like that, it's always useful to understand what the breaking limits are. I like to tie any of our testing tools into CI, that is continuous integration, continuous deployment. Mostly I like to kind of programmatically state my opinions and then codify that in some kind of scripting language and some kind of tool set. In this case, we're using LOCUST.io. We'll look into that just a little bit in a minute. But I like to put that in our CI. So that's just a process that'll automatically run. Every time I push code up, I'll have the option to run that test suite against my new code base. And again, as Kaylan alluded to, when you're having some scalability problems, anytime you're debugging problems that can only happen under load, that's a great time to pull in your load testing framework to recreate those situations so you can debug it on the test server or even potentially on someone's local computer so you can replicate and see what's going on. Oh, this is an important one, and this is often one that gets thrown under the rug. Testing plan, and it sounds so obvious, have one. Some sites would benefit more from a load testing versus maybe some sites would be better focused more on brand testing. If you're doing weather.com, the big weather channel site, That's probably one you want to have a good testing plan around, making sure that you can have a good load test in place to understand that you can handle scalability. If there's a category 5 hurricane that's going to run up the East Coast, you want to make sure that everyone in the US can access your site up to like millions of users can access it within a minute and get up to date information. And it's not going to slow down, it's not going to die, and it's not going to go away. If you're more focused on maybe like a realty company or a blog, maybe there's not as much an emphasis. Having a plan before you even really start development, you should understand how important is it to make sure that all of your features work 100%? How important is it to have testing and scalability and stress testing built into your testing plan? Just have a plan and stick with it. Having this plan will also help on a lot of projects when you get to the end and maybe you're a little crunched for time and the client says, that's nice, let's cut this pesky testing thing in favor of just one more feature. I want just one more feature. And how often do tests really catch something? Well, it's always a problem until it's always not a problem until it is a problem. And then everything comes to a grinding halt. So just have a plan, execute it. So this is interesting. Like I mentioned a little while ago, we're using LOCUST. Why specifically we at MindGrub, and I suspect Pantheon, chose LOCUST over some of the other popular tools. I know there are JMeter and BlazeMeter. Basically, the range of tools range from open source, where it's a lot of setup work yourself, to paid, where it's a lovely tool, but it gets expensive. Some of those are JMeter, BlazeMeter, a few others. Specifically with LOCUST, we don't like having to write XML files, especially where it's some kind of new domain-specific language. I personally hate XML files. I hate having my engineers to learn yet another XML schema, and especially where that schema is non-transferable. And it's just, hey, learn this weird, wonky XML format for this one tool that's only applicable for this one small scenario. I'm not a fan of that. LOCUST uses Python for the entirety of its test. That's a transferable skill. That's a useful skill with cross-disciplinary advantages. So obviously we're going to lean more towards Python over more XML. LOCUST has distributed scalability. This means that if I really wanted to get carried away and I want to understand, like with something like theweather.com, how does the site react under 1 million users? Well, my poor little MacBook Pro here doesn't have enough power to simulate 1 million users. LOCUST has the advantage of it can operate in a primary, secondary, or master slave configuration where you can have just a cluster. I mean, it's kind of the name. You can have a swarm of LOCUST servers all working concurrently with each other to simulate 1 million users. This works really well with the cloud, with Amazon Cloud, Google Cloud, and those sort of things. Particularly, LOCUST works really well in Kubernetes, which is just a tool we use to scale out our cloud infrastructure. Python has concurrency, which is a big plus. That means the resources that you allocate to it, it's going to use really, really, really efficiency. Python is one of those languages that's been around for a long time and handles parallel computing really well. Again, doubling down, I hate XML. Didn't want to have to learn it. Didn't want my engineers to have to learn it. We also like Python. It's a fun language. And it's open source. This was big for us. This is big for Pantheon. The fact that it's open source, it's something we can go in and see what the kind of inner workings of it are, also gives us the opportunity to kind of give back to the community. Ah, yes, live demo time. So we will be testing the old mindgrub.com website. This is our website. Truthfully, there's nothing special about it. It's yet another agency website. But it's something that I was able to have easy access to, so we're going to subject it to as much load testing as I can muster up this afternoon. So again, I mentioned that all of the LOCUST tests are written in Python. Again, I'm a fan. This is great to have some of our engineers or our QA folks learn. These are skills that they can go and we can work on other Python applications or use other tools. Again, big fan of Python. But the core of it is we have to define our basic website user class. And it's going to basically just give it some kind of meta information about what our task set is. Our task set is nothing more than a list within Python. Think of this as a to-do list. This is just a list of items we're telling it to go through and do as a part of this test. Wait time is a configurable. I want to simulate real traffic, so I'm just going to tell each one of the tasks to take between 5 and 15 seconds. To kind of, we roughly have guessed on a MindGrove website, this is about how long folks will take in between loading a page, reading some content, and clicking a new link. Our task set are really easy. They use these what are called decorators. They're just this little annotation that goes over the method declaration to identify this as a task as something we'd like for it to run through and do. So I'm just telling it to go through, and I want to load the about page, the service page, and the work page. LOCUST works entirely with an HTTP client. So we're not actually loading the full web page in this instance. We can do that, but for testing purposes, we just want to use the HTTP of the page. This is similar if you ever go to the web page and click view source, view page source. This is really all I'm doing. I'm just asking the website for the HTML, and then Python's going through and interacting with that HTML. I'm not doing anything like loading JavaScript or anything like that, though we can if the need were to arise. So I'm now going to run that same locust file, which again, I'm just saying, hey, locust is my tool, run this locust file. I'm giving it a default host name just to make sure that I hit the MindGrove website. I do this because I want to be careful to make sure I don't hit our production site. It actually has the capability to DDoS your entire site. We are load testing. It can load test successfully. So if you look in the terminal, launching this by default launches it with its own little server and GUI interface you can go through. It's going to launch it on this port. So I'm just going to go over to my web browser, type in localhost, that port, and voila, I now have this interface where I'm gridded with two large input boxes. I can ask it, it'll ask me how many users I want to simulate. Let's say I want to see how the site survives under 1 user or 100 users. And hatch rate is just how fast per second those users will accumulate. We can use this to indicate like how quickly the traffic will go from 0 to 100 in this case. In this instance, I'm just going to say add a new user every 1 second. This is useful. A lot of servers will slowly start to adjust over time to traffic loads. Pantheon's actually really great at this. As it detects increased traffic load, they will often spin up additional web servers to kind of run in parallel. Pantheon's using Docker and Kubernetes, so they're containers, not server, but the concept still holds. It'll detect the incoming traffic and the extra resources being used, and it'll slowly start to ramp up and ramp up and ramp up so you can handle more traffic. That's where we can dial in and see what effect that has over time by using the hatch rate and the overall user amount. So you can see here, and I'm actually using a different locust file, but you can see here kind of an overview of what it's doing. It's going through making requests to a lot of random pages, and it will track any failure rates and roughly the estimate time that we're expecting those pages to load. We can set specific requirements about what our expectations are for failure or passing with how long the page loads take. Also, asterisk, I have turned caching off because I wanted some interesting results on our testing site. So it also gives me these nice graphs, which are great to look at. And I find these are a great communication tool when I'm having to abstract and go from a very technical analysis of how the performance testing went to maybe the client or the owner of the website. I find that they have these graphs. They're much more easier for them to understand and for us to articulate what the problems and concerns are. These graphs aren't directly exportable, so typically we'll just take a screenshot of what it looks like when we're complete with the test and use those and add those into our ticket or Basecamp or Google Docs or wherever we store this information. But we can export that out. So it also keeps track of failures separately if you wanted to isolate those. So you can see here I'm getting a failure of just, I'm not able to load this page because, as the name implies, it's not a real page. But I wanted to demonstrate what that looks like. So we can kind of get a list, and after this load test was complete, we could go back through and see exactly what failures we have, if there was any exceptions or issues with the load test running in. And usually these would be the things we would go and start to run down and see where our issues were. If we wanted to download the raw data, it all comes in a CSV. It's very raw. There are some tools you can take to take the CSV and then translate that into graphs, but that's a little beyond the scope of what we're wanting to do right now. While the test is running, at any point, I can stop it, of course. I can also click a new test. If I wanted to adjust these numbers without having to go back to the terminal and re-click things, I can't do that here. I could do things like, what happens if I add 1,000 and 10 users a minute? And the answer is my website's going to scream and cry. So I'm going to stop that real quick and go back to my locust Python file. This is, again, just the Python we're looking at. This one's just calling 3 specific pages. Maybe in this load test, I think these are our problem pages, and I want to see how they react under load. Sorry, the meetup thing is getting in the way. Oh, there we go. So this is a little more complicated. And this is, again, why I love Python. If you are comfortable with Python, and even if you're not, if you've written PHP, I feel like Python is very easy to dive into. You can go in and really test anything you want to. So again, we're going to define our task list. I'm going to, again, set the page request between 5 and 15 seconds. And I, again, have defined some tasks. Here, I have a kind of global method that's available if I want to log the user out, which kind of gives some foreshadowing that we've now coded in a way to log the user in. This is kind of a fun little method that does nothing more than just crawl your entire site. My dog's really into this presentation. Just crawls your entire site. We'll index all of the pages and links it finds. We'll do some basic sanitizing to make sure that we're not looking for external links or telephone numbers, but then we'll keep those in a list and we'll just randomly start hitting those. That's a great way to just test what anonymous traffic looks like over the entirety of your site. And again, we go through and we can set some specific pages. You can see here, though, on my task annotation, this decorator now, I have numbers in the actual decorator itself. This will this will call these individual methods based on a percentage of themselves. I usually will set my first method to 100 because that's easier math to me. So I'm saying I want everything to be out of a percent of 100. So every single task, every time it simulates a user, 100% of the time it will call the home page. 20% of the time we'll call the about page, 50% services, and so on and so forth. I did want to come down here. Again, I was talking about HTTP clients a little bit earlier. Because we have access to a full robust HTTP client, we can do things like post. That means we can store a session ID. In this case, I'm logging in as this actual user that I created for the purposes of this demo. We'll log in, and then for the entirety of the session that this user is active, they will then act as this user. So we can both test how anonymous and logged in traffic behaves on the site. We obviously can go much more in depth if there's a single sign-on, or we're going to do something more complicated workflow to understand how different operations performed on the website under traffic. We all could do that within Python, which is why we prefer this over XML by a long shot. So I'm going to go ahead and stop this. Once you stop it, you'll get this nice little report. So I mentioned earlier, to close this, I don't actually like running this, and it's great that we can run these tools. We'll always put these in our projects themselves. And I have to apologize, this is not working at the moment, but this is how we would typically run, we want to run the testing suite, and this is available to anyone on our team. This is just our Git repo for our MindGrub website. Because we're using GitLab, this also works in GitHub and Bitbucket or any of the major providers. I'd come over here to CI/CD, continuous integration, continuous delivery. and I would just click Run Pipeline. I've already defined this as an action I can do. And to make sure I didn't typo these wrong, I have already pre-filled the information in. So I want to run a specific pipeline. I'm just going to come down here. I want to run it against the LOCUST branch just because that's where this work is. And I can pass in variables. So we have ours set up to where if I forgot to do this, it's fine. It would just stop. But I'm going to say, hey, I want you to run our LOCUST test suite, and I'd like you to run it on this domain. This is our test domain. This is great. Maybe Kaylan's working on a completely different feature, and I want to test that before we even merge it into the test server. If it has a URL, we could do that and run the entire testing suite. I would then click Run Pipeline, and we have this all set to manual. We don't automate some of our large and time-consuming test suites, but I would come here and hit play. We currently have a problem because we've upgraded our GitLab server, but if I hadn't updated my GitLab server, basically it would run exactly what we've already run through the GUI. The only difference is we'll just run it without the GUI, and we can pass in some more specific arguments. So this is doing the same exact thing as the GUI. It's going to track all the information. And at the end of this, it basically will give us an exit status of pass or an exit status of fail. If it does pass, that means that the build is successful and we could deploy that if that was something we wanted to do. If it failed, we would then report that, and usually failures spam lots of people on the project teams. Cool. Both of my dogs are now starting to circle around me because it's dinner time. Cool. So I forced it to end early, but this is just kind of the last report you'll get, and this would be a pass build, which would give you a green check mark in any of the hosted version control software, GitLab, GitHub, Bitbucket. This would just give me the final printout and give me the green checkbox if I wanted to move forward with this deployment. Live demo successful. Any questions around that?
No questions, but that was pretty awesome, man.
Cool. So a bit of a story time. Kayla and I actually work together now, and our relationship, Pantheon is obviously a very robust hosting company that excels in the Drupal space as well as WordPress and some other things. We are a builder of Drupal things as well as some other things, so we often work together to launch projects. Oftentimes it's we'll build it, we'll try to host it on Pantheon or sometimes elsewhere. But this is the relationship Kayla and I have, and I have a story of how this personally affected our development process. So we had a Drupal site that, for reasons beyond our control, despite our request, was not hosted on Pantheon. So I'm going to make that clear. This is not anything against Pantheon. Actually, Pantheon may have added additional support to help us here. But we had a Drupal site nonetheless that just its entire purpose was to collect extremely large data collections. And its entire business model was we would collect this data and you could subscribe to get access to it in a very nice, curated way with beautiful graphs and things. And it was for a new startup company. It was fine. Everything was lovely. They were about 4 years old and chugging right along. And this is actually an interesting project. We built it for them how they asked 4 years ago, and we continue to build it for 4 years long. And they very much had that startup mentality of we only have 6 months of runway. We have to build as much as we possibly can. Screw the test. Let's get as much out the door as possible. We're only focused on user growth because we need user growth to survive. We don't care about testing. So this is how it went for 4 years. And for 4 years, it was great. It was great and grand. They had moderate success and growth. All of the metrics they cared about, their user growth, the amount of time people spent on the site, was all increasing. They were getting more subscribers. They were making more money. They were happy. About a year ago, we started to raise some red flags on our end. Hey, we think your technology is starting to age. We think your technology is starting to age. We'd like to start talking about running some tests or upgrading. We need to do something about all this technical debt we're accruing. And they said, that's fine. And then August rolled around and the site seized up for about 5 minutes. Now, this is a large site, so we put a lot of time and effort into having reporting. So even though it was off hours, it was 8 p.m., we all got email alerts that the site shut down for 5 minutes, 8 p.m. one day. Alarmed, we don't know why. The client doesn't know why. So we spend a day investigating, tell them, we don't know what happened. We don't know why. Nothing jumps out at us. They say, don't worry about it. It was an anomaly. Get back to cranking out more features, please and thank you. So we do. September rolls around. Happens again for 10 minutes this time. Well, that's alarming. Same story, different day. Rolls around, same solution. Spend a day looking at it. Can't find any hard evidence. They're not willing to stop throwing more features at the dartboard because that's what counts. And then November rolled around. And it happened, and we alerted them to it. No big deal, 15 minutes. And then late November rolled around, and it happened, and it wouldn't stop happening. The site went down. Everything seized up. We couldn't get access to the site. And this is actually a graph from around that time. These are just our database servers. We have 3 database servers running, all to try to support this traffic load. And suddenly, for no reason we understood why, the 13th, all of a sudden, everything hits 100%. And we try some things, these blips of recovery. The only thing we can do to get the site to come back up is to turn it in maintenance mode and lock every single user out of the site forever. As soon as we turn that off, right back to 100%. We can't get the site to unthrottle. I also have this little arrow up here because I find it comical. This is on AWS, not with Pantheon. AWS gives us these graphs of how our database servers are surviving. Everything's at 100%, but they put 120% on the graph as if they could do a little bit more if they were really trying. Nonetheless, we're capped at 100% though. No 110, 120% effort from our database servers. So now we're in a panic. We don't know what to do. Now the client finally cares because their paying customers are now stopping to sign up and starting to call them threatening to cancel. We're in full panic mode. What do? Well, our approach is to go through things like New Relic and start throwing performance testing at it. The client's preference is we just throw money at the problem. It's no big deal. For reference, each one of these database servers this is what it's called. It's an R4 large, but it's what we felt was reasonable at the time. We've got 3 database servers running with 2 CPUs and 16 gigs of RAM. Their throw money solution at the problem was let's throw more app containers at it. That's what we'll do. We'll spin up more servers. Well, it turns out that's not the right answer. Spinning up more app servers, all that does is teach us that we can crash the servers even faster. More traffic's actually bad, so we just find new ways to kill it faster. So their suggestion is, okay, let's throw more money at a different problem. Let's give it more database problem. We go from, again, 2 CPUs, 16 gig servers to these things called 8x larges, which are, as the name implies, 8 times the size, which we're now at 244 gigs of memory per database server. Also, for a fun fact, this jumps you from a reasonable hosting bill. Running 3 to 5 of these a month is about $60,000. So we went from a normal hosting fee to about $60,000 overnight, and we're still not fixing the problem. So this is not exactly our output from LOCUST, but these are some of our outputs from some of our performance testing that we threw together last minute to try to identify the problems. We finally found our problems. It was a few database queries that had worked fine for 4 years. Apparently, we had ingested a new large data collection. It added about 1 million new nodes to the table. Again, not a big deal. We thought we had 3 million nodes previously, went from 3 to 4, and then we had a new influx of users. This is I actually can't fit the entirety of this query on the screen, but this is the query that we were all fine and dandy with and worked fine. At the end of the day, our problem was, this also is my favorite. This is the comment that was above the query that we all just assumed worked and hadn't honestly touched in 4 years. says, as far as I can tell, this just works. Have no idea how. I'm scared to touch it. And that's kind of the consensus all the engineers had on the project. Our resolution was we ended up just having to go and refactor those. There were queries that operate perfectly fine until you introduced that size data set and that number of users to the equation. It was a problem where we were multiplying x times y times z, which was perfectly fine because for the longest time, z was 1. And suddenly x went from 3 to 4 million. We added a bunch more users, and z went from 1 to 100. And it just logarithmically scaled the amount of traffic, the amount of load that our system was under unexpectedly, and we weren't able to survive. The resolution of the story was it took us about a month and a half to fully stabilize the service. It cost our client a lot of time. It cost our team probably 3 weeks of 80 hours plus for the engineering group to get this back on, all because overall we didn't have a load testing framework in place to give us any indication that the dam was starting to crack and that we weren't prepared for the next oncoming flood that was right around the corner. Pretty much in conclusion, skipping load testing will be expensive later. Again, it's a problem. It's not a problem until it is a problem. It was extremely expensive for us and the client. Locust is amazing. It's Python. It's scalable. It's fast. It's easy to set up. Would highly recommend. Slides will be available. I already linked them in the Slack, so if anybody has any comments, questions, concern, feel free. It's also our slides, giving back to the concept of open source, are also on GitHub. They're open source. If you want to take them, you can. If you want to make recommendations to them, you can. If you have a comment about them, you can. It's all on GitHub, so feel free to like, comment, make a merge request to your heart's content. Finally, here's a link out to Locust notes. This is just the locust.io webpage. The documentation is actually really nice. The community is pretty warm and welcoming and active, which again is another good sign of a solid open source community. Finally, go forth and do awesome. Any questions?